that means in place of x now we have 1. X belongs to A. Suppose this is A and this is B. Whether 1 also belongs to B? Yes. Then next comes 2. 2 is in A. Is 2 in B? Yes. So A is a subset of B. Note that we do not have to bother about 3. We only have to look for the elements of A and see whether they belong to B as well or not. In the same vein, this is also a subset of 1, 2. Because you choose this element 1, it is there in the second set. You choose this element 2, it is there in the second set. So this is a set is a subset of itself. That always happens. Okay. However, if you switch the orders of these two sets, then the thing does not happen. This is not a subset of this. Why? Because although 1 and 2 in the first set are also there in the second set, 3 in the first set is not there in the second set. So this fails to be a subset of this. You can already see that subsets are inside the original set in a sense, a part of the original set. That's why they are called subsets. Okay, so you see, 1 in a particular sense, 1 is also inside 2. How? Because 2 is equal to 1 plus 1. 2 is 1 plus something extra. So that's why we use a notation like this. 1 is less than or equal to 2. Now, if you look at this notation and instead of making it a pointy one, if you mold it, you can see that it becomes this. So that way you can remember that the smaller set is the subset of the bigger set in a sense, and you can use the notation much like how you use ordinary order relation among numbers. Okay, so that is the idea of a subset. And when subset is not a subset, you see anything, any relation, when that does not happen, we denote that by the same notation, except the symbol is has a dash. It is struck off. Okay, so that's what subset means. And when subset comes, another thing also comes along with it, that is the idea of a proper subset. A set A is called a proper subset of a set B if A is a subset of B and A is not equal to B. Okay, A is a subset of B, but at the same time A is not equal to B. Then A is said to be a proper subset of B. This is somewhat different from, although related, but somewhat different from being a subset of B. For example, this is I have to write a notation. So we denote this fact by writing this. It is like 1 less than 2. Okay, not less than or equal to, less than 2. So while you can write 2 less than or equal to 2, but you cannot write 2 less than 2. So A is less than B means A is inside B, but B has something more. So A is properly contained in B, or B properly contains A. We just remove these equality bars. Okay, so coming back to the example, this is a proper subset of 1, 2, 3. Why? Because already this is a subset of 1, 2, 3. We already have seen that but at the same time this is not equal to this, because 3 here is not here. So this is a proper subset. This is a stronger relation than being a subset. It says something more, that the second set, the larger set, is actually larger than the original subset. Okay. And now there are several ways of saying these things. Okay. If A is a subset of B, we say A is contained in B, or B contains A, or B is a superset of A. Now this is a new name. Okay, it comes along with subset. When A and B are given and A is a subset of B, then B is the larger set, so it is called a superset of A. B is a superset of A. So these things mean the same thing, that A sits inside B. Whether they are equal or not, that is not clear from this relation. This relation only says that A sits inside B. It may or may not be equal to B. If it is equal to B, then fine. If it is not equal to B additionally, then A is a proper subset of B. So in the same way, if A is a proper subset of B, we say A is properly contained in B, or B properly contains A, or B is a proper superset of A, similar to the ones above. So these are the ways of saying this thing. Now some examples will clarify this further. So let us see those examples. Example means just like that. 1, 2 is a subset of 1, 2. Okay, so this is one thing. 1, 2 at the same time is also a subset of 1, 2, 3. One, 4 is not a subset of 1, 2, 3. Okay. 1, 2 is not a proper subset of 1, 2. You see the relation when it comes to subset, every set is a subset of itself. However, no set is a proper subset of itself, because for being a proper subset, this condition is true. Okay, for being a proper subset, the first condition is that it has to be a subset, but then that being not equal condition is there. Clearly this is false. Had this been true, we would have had 1, 2 as a proper subset of itself, but that is not the case. This is false. So a set is never a proper subset of itself. Here, however, in the second one, we see that this is also a proper subset of this. So this relation tells you something about the set. 1, 2 is contained inside this, but this relation is stronger. It tells you even more. It not only is contained in this second set, but is contained properly. That is, the second set contains something other than the first set. That condition is not needed in the relation of subset. That something extra should be there, that is not needed. That's why you have this also. 1, 2 is a subset of 1, 2. Okay. And here, of course, again, this is not a proper subset of 1, 2, 3, because here, first of all, the subset relationship itself is not satisfied. So how can it be a proper subset? So I hope these examples make it much more clear now what sets and subsets are. Subsets are smaller than sets. Proper subsets smaller or equal. Proper subsets are actually smaller than the given set. Okay, so now one thing, if you look closely, you will see that for sets A and B, we have A is equal to B if and only if, you recall, if and only if from mathematical logic, A is a subset of B and B is a subset of A. If A is equal to B, then of course this is true, because you actually have this, which is true. We know every set is a subset of itself. So if this is true, then this is true. Remember the truth table. If and only if statement is true when either both the statements are true or both of them are false. Okay. So if this is true, then this is true. However, how to come from this side to this side? So now we assume that A is a subset of B and B is a subset of A. Okay. So from this, how do we conclude that A and B are equal? Because A is a subset of B, every element in A is already in B. So A sits inside B. Now, is there something more in B? If there is something more in B, that means that more will not be in A. But that is not the case, because B is also a subset of A. So A sits inside B, B also sits inside A. So this can only be possible when A and B are equal. So this implies A is equal to B. Now this is a standard procedure for proving that two sets are equal. You show this and this. Okay, when you are asked to show that two given sets are equal, you show that either of them is a subset of the other. That is the standard procedure. And this equivalence is called the principle of extensionality of sets. This equivalence. Okay, two sets are equal if and only if either of them is a subset of the other. This is the principle of extensionality of sets. Now, as I have already told you that capital letters are used to denote sets, but some special symbols have been reserved for special sets which arise most often in mathematics. So the symbols are like this, and some sets